Good morning, everybody. This is Madhavilata Sampangula, working as head of the department in Government Institute of Printing Technology, Secunderabad. Today, we are going to discuss about the history of the lithography and how it has been transformed to offset, which is an indirect process. Before going to know about this, we will recall the principle of lithography. In ancient Greek, litho means stone and graphy means writing. Therefore, lithography means writing on stone. The inventor of this process was Alois Senefelder, and he invented this process in the year 1796. As we know, the underlying principle of lithography is water and oil do not mix. They both repel each other. Unlike letterpress, there is no physical separation between image and non-image areas. Both are on same plane, but are separated chemically. Non-image areas are treated with gum-arabic solution to make them water recipient. Now, though the image areas and non-image areas are on the same plane, image areas are made oleophilic, that is attractive towards oil, and hydrophobic, that is dislike towards water. In the same way, the non-image areas are made hydrophilic, that is attractive towards water, and oleophobic, that is dislike towards oil. To get a print initially, the image carriers which consist of both image and non-image areas is to be moistured with water. The image areas which are greasy in nature will not receive water, but non-image areas will receive water. After this, the image carrier is supplied by ink. The non-image areas which are already moistured with will repel ink, therefore only image areas receive ink. Now the substrate is placed on the image carrier and impression will be given to transfer the ink from the image carrier to the substrate. The whole procedure has to be repeated for each impression. And like a letterpress, this is also a direct printing process since the substrate is having direct contact with the image carrier. Now we will see a video which shows us clearly about this process.
Welcome to Steve Draws. I'm Steve, a Dutch illustrator and animator, and this video is about stone lithography. I got to do a workshop about stone lithography, and in this video I'm going to explain how stone lithography works and who invented stone lithography. I already made a video about stone lithography some years ago for a dear friend of mine, John Robin, and he's an art broker, and he had an exhibition about the stone lithographs of Michael Parks, which is an American artist, and Massimo Rao, an Italian artist. And I'll leave a link in the description box down below so that you can see the movie, and it's about the process of stone printing by Michael Parks. But it's a whole different story when you do a video about stone lithography and you've never really made one yourself. So now I got the chance to do a stone lithograph and had a workshop in Valkenswaard. And Valkenswaard is in the south of the Netherlands. So I drove down there to the Nederlands Steendruk Museum, and that's the Dutch lithograph museum. And I got a tour around the museum, and they got a lot of cool things to show. So old presses, and the first press that the inventor of stone lithography made. After the tour through the museum, we got the chance to do our drawing on a stone, and I'm just going to show you the video now and going to explain how I made my first stone lithograph and what you need to do to print from a stone. Stone printing is one of the oldest forms of printing images. Before that, when a book had an image, they were all drawn and painted by hand by monks. That was very time consuming. They invented etching so you could print pen drawings, and in Japan they used woodblock prints to print images. But both of these methods were very graphical. Stone printing was invented by Alois Senefelder. He experimented with an etching technique using a greasy acid-resistant ink as a resist on a smooth-grained limestone. In 1796 he found the solution and made his first planographic print. Planographic is printing from a flat surface. He perfected the technique and was now able to print sheet music. He also invented the first stone print machine, the print from stone. Senefelder wrote a book, Volstandiger Leerboek der Steindrukkerij, which is still used by lithographers to this day. Lithography was perfected and later used by artists such as Toulouse-Lautrec and Pablo Picasso. It was a perfect way to reproducing posters in full color. Books were printed and a lot of other things. When offset printing was invented, stone lithography became a novelty and is now used by artists who want to make art in a direct way. So how does stone lithography work? You draw on a grinded limestone with a very smooth surface. You can sketch with a graphite pencil on the stone to set up your drawing. The graphite pencil won't be printed because it's not greasy. You have to protect the stone from your hands and fingers because they can be greasy and you'll otherwise end up with fingerprints on your artwork, and you don't want that. So I made this sketch of an otter on the stone with a normal pencil. But you need a greasy pencil for the stone printing to work. You have 5 different pencils you can work with. One is the most greasy pencil and you can make very dark strokes with it. And number 5 is the most precise and subtle pencil you can use. I drew this picture with a number 4. I used some different techniques just to try out how it would work out. I did some cross-hatching and some gradients with little points. I also tried to make a smooth gradient with the greasy pencil, just to see how it would end up in print. When you're finished with your drawing, the stone is prepared with French chalk powder. This helps to protect it for the further process. The stone is then processed with a mixture of gum arabic and nitric acid. The gum separates the image area from the non-image areas. This is the etching of the stone. The drawing will receive the ink and will repel water. Usually you have to leave the stone for 1 day so the etching can take place on the surface of the stone. Then the stone is placed on the printing press. With turpentine oil the image will be washed off the stone. After that, the stone is prepared with a thin layer of oily ink. By doing this, you remove the water-soluble gum edge. Now the stone is ready for print. The drawn image receives ink and the rest of the image receives water. Before printing, you have to keep the stone wet with water, so that the ink will not print the empty areas. On a piece of glass you mix the ink and roll it with an ink roller. Before applying the ink onto the stone needs to be wet. You roll several times on the stone with the ink. Then you need to fan the stone so that the water dries. Then you can apply the paper onto the stone. On top of the paper, a plate of leather is placed with a bit of ox gall. This helps the stone glide under the printing press. You move the stone under the press and then turn the lever to press down the paper onto the stone. With the turning wheel, you move the stone and the paper under the press. Then you release the press with the lever. Then you remove the leather plate and carefully remove the paper from the stone. This is my first stone print I've made. For each print you have to repeat the same steps: wetting the stone, apply ink, fanning the stone, paper on the stone, and printing the stone onto the paper. I hope you enjoyed this video. If you like it, please give it a thumbs up or subscribe to my channel. You also
So I think with this video you got a clear idea about this process. Because lithography is a direct process, the image on the image carrier is in reversible form, that is mirror image. We may face some problems to do proofreading and corrections in this process. Moreover, the image carrier is a combustion and a heavy stone which cannot be carried very easily. These two drawbacks are overcome by the introduction of zinc plates by about 1820 and the placing of a rubber blanket in between the plate and the impression cylinder. In this juncture, lithography has been transferred into offset lithography, that is an indirect printing process. In this offset lithography, which is an indirect process, the image carrier and substrate will not have any direct contact. The image from the image carrier transfers ink to the blanket and from there to the substrate. So, no mirror image on the image carrier. That's why proofreading become easy. Because of the flexible zinc plate, the image carrier, that is zinc plate, can be mounted on a cylinder which is known as a plate cylinder. By the use of the plate cylinder, blanket cylinder and impression cylinder, the speed of the press also increased. Now we see the historical development of offset lithography. Before going to know about this, from 1436 to 1796, letterpress only ruled the printing industry. In 1796, Alois Senorfielder invented lithography, and in 1820, the zinc plates were introduced in lithography instead of a combustion heavy stones. And in 1860, a photographic process was being used to form an image on the plate instead of a hand drawing. After a very few years, an ink attracting and water repelling image is formed on the modern aluminum plate by photographic means, because the zinc plates are little bit heavier and costlier also. That's the reason the zinc plates were replaced with aluminum plates. But nowadays also zinc plates are, we are using zinc plates. The life of the zinc plate is very high when compared with the aluminum plates. And then we will see the whole process of printing in a video now about this. Just a minute.
Offset printing is one of the most common image reproduction methods of the modern age. But what is offset printing, and how does it work? Offset printing begins with the pre-press stage, where digital files are broken down by their color separation and are laser etched onto coated aluminium plates. Each plate is then loaded onto a roller known as the plate cylinder. Each revolution of this cylinder dampens the non-image area of the plate with water from the dampening system. A vegetable oil-based ink is then passed through a series of rollers and finally onto the image area of the plate. This image is then offset onto another cylinder with a rubber blanket. The addition of this process results in a clearer and sharper final image and is where offset printing gets its name. Paper is loaded into the start of the press and is separated by jets of air to ensure that only one piece travels at a time. The paper is passed between the blanket cylinder and the impression cylinder, where it receives the printed image before it's passed on to the next unit to receive the next colour. After the page has travelled through each of the units, it is piled at the end of the press with a thin layer of powder separating each page so that the printed image can dry without marking the pages above and below. Offset printing is best suited for larger volume prints, as most of the cost is in the initial setup, and the price per print will fall as the quantity goes up. For more information, visit us at expresscards.com.
Now I think you have got a clear difference between lithography and offset printing, though both are working on the same principle, that is, water and oil do not mix. We will see now some of the key points are points to be noted. The use of this soft rubber covering on the offset cylinder allows a variety of coarse surfaced papers to be printed by this process with success. Before that, when there was only a direct printing process, very few varieties of papers only can be printed. Because of the rubber surface, the coarse rubber surface, we are able to print on a wide variety of substrates nowadays. Most of the aluminum plates used today carry a tough coating of aluminum oxide on the surface, which gives the plate good water carrying properties together with corrosion resistance. Definitely, the non-image areas always should have water carrying property, because the aluminum is a metal plate and it has the tendency to get corrosion. So it should be, the corrosion also should be resistance. For that purpose, the aluminum plates were coated with aluminum oxide, that is also called as anodized aluminum. The non-image areas of the plates are treated with gum-arabic solution to make them water recipient. The fountain solution additives such as gum-arabic or alcohol are added for in our fountain solution to protect the non-image areas of the plate. So the for each and every impression, the non-image areas of the plate should be moistured with the fountain solution. So for each impression, when fountain solution is applied, if you are having some additives like gum-arabic or alcohol, or in some areas plate etch solution also, those will protect the non-image areas of the plate. The non-image area always should have the water recipient character. So to protect that water recipient character, we are adding certain quantities of gum-arabic or alcohol in the fountain solution itself. The pressman will often use an acid-based solution called plate etch for cleaning the non-image parts of the plate. Sometimes when we are printing, the non-image areas will receive a little quantity of ink. Actually, non-image areas should receive only water, but because of the diminishing the characteristic of the non-image areas, sometimes the ink also will be attracted by the non-image areas. That should be cleaned for each and every impression. Plate etch is necessary for removing ink which has become attached to the non-image areas of the plate. With this, I want to conclude here, and in the next video, in the next class, we will clearly discuss about the sheet fed offset machine and how the sheet fed offset machine is constructed, what are the parts of sheet fed offset machine, and the purpose and properties of all the parts in the sheet fed offset machine. Thank you for listening.